The topic I'm going to talk about is why the Antarctic ozone hole goes through a seasonal change. The first part is the general introduction of ozone layer. The ozone layer is a region of Earth's stratosphere that absorbs most of the sun's ultraviolet radiation, protecting the lives on the Earth's surface from being exposed to UV and therefore being endangered. About 90% of the ozone in the atmosphere is contained in the ozone layer, but the concentration is still quite small, which is less than 10 ppm. Ozone in Earth's stratosphere is created by ultraviolet light striking ordinary oxygen molecules, splitting it into two individual oxygen atoms. Then the atomic oxygen combines with unbroken oxygen to create ozone. O3. While most of the ozone is indeed created over the tropics, since UV there is the strongest, the stratospheric circulation will transport it forward and downward to the lower stratosphere of the high latitudes. Therefore, the concentration of ozone should be highest in poor area. Ozone can be depleted by free radicals. Since the late 1970s, a larger springtime decrease in stratospheric ozone layer around Earth's polar regions has been observed, especially in the Antarctic region, which is referred to as the ozone hole. The root cause of ozone loss over the Antarctic is man-made CFC, a compound consisting of chlorine, fluorine, and carbon, and halons, consisting of bromine, fluorine, and carbon. Each year, the Antarctic ozone hole goes through a seasonal change. A dramatic thinning of ozone begins in July and shrinks in November. So in the second part, we will talk about the reasons of this phenomenon. Between spring equinox and the autumn equinox, the South Pole becomes tilted away from the sun, which causes a polar night, making the Antarctic stratosphere cool down. And polar vortex, which is westerly winds, becomes stronger when winter is coming. It effectively isolates polar regions, trapping and chilling air. Because of these two factors, by around late May, the temperature starts to be lower than minus 77 degrees Celsius, and therefore PSCs, short for polar stratospheric clouds, began to form. There are three types of PSC clouds, and they have two important influences. The first one is that it provides surfaces for chemical reactions, and the rate of surface reactions are much higher than the common ones. The heterogeneous reactions on PSC particle surface convert chlorine reservoir species, mainly including CaONO2 and COCl, to CO2. Another influence is that large nitric acid hydrate particles in the PSCs can sediment out, removing HNO3 from the stratosphere. In August or September, since spring is coming, sunlight begins to increase and the temperature goes up, causing PSCs start to evaporate. CO2 that had accumulated from PSC heterogeneous reactions can be photolyzed to two chlorine atoms and then convert ozone molecules into oxygen molecules while regenerating themselves. Through this process, a single chlorine molecule can lead to the destruction of about 1,000 ozone molecules. And because HNO3 has been removed by PSCs, there is not enough NOx to remove ClOx, and the reaction of ozone loss based on bromine are similar. By late September, the ozone loss peaks. In late spring, which is November, Antarctic vortex breaks up, so ozone and NOx in the mid-latitude can mix in. NOx converts some chlorine and bromine to reservoir species. Therefore, the concentration of ozone increases and ozone hole gets smaller. And let's get some direct impression of this seasonal change from pictures and videos. This picture describes the ozone mass deficit change within a year. We can see that the dramatic loss of ozone starts from late August and ends in November. And this is a figure of ozone hole area change within a year, and it follows the same time pattern. In addition, from these two figures, we can see that the ozone hole situation is getting better these years, thanks to Montreal Protocol. And there are two short videos for you to see. This is the ozone concentration over the Antarctic area from July to September. The bluer color means less ozone concentration. And this one shows the ozone hole in September from 1979 to 2017. It got worse in the last century but has been ameliorated in recent years. That's all. Thank you.